So today is 23rd of April 2025. I will do basic linear regression review and also questions on MLE and how can we, from the very minimum setting of MLE, which is point tossing, to how can we extend it to geometrical statistics. I will talk about this one. First, linear regression review. If there is 34 samples and 7 explanatory variables, then then there's always basic things, which is SSR, SSC, SST. Each of the degree of freedom is m minus p minus 1, p and plus m minus 1. MSR can be just divided by this degree of freedom, then you can calculate it easily. You need to also think about OLS in very basic things, like when there is 2 points and when are 3 points, how can we do OLS? And so for the matrix format, beta hat equals to x transpose x minus 1 to x transpose y. And this MSE multiplied by x transpose x, then for each of the term, you can get variance regarding term, which is used later at this part. Here it says s squared, then and also about p-value, which is 2 multiplied by 1 minus CDF dj, which will be critical value. And there were related functions in Python will be ppf and CDF. The CDF will be input, output, and ppf will be CDF's inverse function, significance level, and critical value is that that's important. And for the first problem, the shape of their distribution varies depending on its degree of freedom. Among the following degrees of freedom, which one yields the highest probability density x equals 0? Maybe I tried to do it by looking the t table and by t distribution function, but actually the most intuitional answer will be t distribution. If degree of freedom goes to infinity, it follows normal distribution. Then in normal distribution, it's symmetric, and when x equals to 0, it has the highest part. So yeah, yeah. If someone asks which one is the highest probability density at x equals to 0, then it will be x equals 0. And second, in a linear regression model, there is 29 samples and 6 explanatory variables. If you want to check the significance of the model, F test, which is each of the from beta 0 to beta n, we will assume it's 0, and if it will be null hypothesis test. If you do it, you can do it with F test. Here, if your significance level equals to 0.01, the star equals to MSR over MSC, so you can calculate it by uh, explanatory variable is 6. So SSR divided by SSR, and for SSC, uh, divided by 29 minus 6 minus 1. And we can calculate the SSR and SSC. Then you can compare with critical value or critical value, which is 6 k and minus k minus 1. And uh, significance level. And for the third problem, it is about significance of individual variable in a linear regression model using t-test. So of the significance level is 0.1. You can use degrees of freedom is n minus k plus 1, which is same with SS is degrees of freedom. Well, this one you can calculate it by multiplying MSC with X transpose X inverse matrix. Next problem is logistic regression model, which trained on binary classification data. You can find logit function as write down the logit function like this. Then odds will be e to the log odds. Then you can get the answer. For the problem 7, it was using the marginal probability of PA1, PI multiplied by PPI. But in this case, we can find PP3, so I used P1 minus P1 minus PP2 equals to PP3. We used total law of probability. And for the explanatory variable, when x is binary among the samples with class level 0, the values of x are given as 0, 1, 0, 1, 1, 0, 1, 1. Then estimate the parameter of class 0 of this variable using the naive Bayes classifier. It was a bit questionable because I actually used MLE. MLE is what it actually does is based on case we observe, we will make probability distribution that the observation is reasonable. So what we are doing is following. We'll make probability distribution like this. Then if we go more detailed settings, it is, let's say there is statistical manifold, which is p theta x. Theta is like following. When x, x is following, let's say it's a coin, then let's say x is element of h, then theta, and x is element of t, then it is 1 minus theta. P theta x equals to theta. P theta x equals to 1 minus theta. Then theta. Then in this case, H is discrete variable, and it will there will be function to manifold, which is probability distribution of PS. Then let's say we did twice, and it was HTTTT. What we want to do is I want maximizing 1, 2, 6 is the top exact. Then we can of course, for the convenience of the calculation, we can add log. Then after that, if we just partial derivative with respect to theta, then we will get probably theta equals to here. Yeah, that's right. Already, then we can get proper theta. And what I want to do is this was the very basic set of MLE. Based on this, we will do consistency proof. Where the consistency proof. And the base pipeline. For Laplace smoothing, what we can do is we got MLE for Bernoulli by process what we already did. We can notice theta equals to overlap. We can also get for MA theta for MAP theta is MLE. Yeah. With this, I will I'll extend it later. Thank you.